Hello everyone. In this video, we're going to apply what we learned in our last video about Boolean conditions to conditional statements. Specifically, we're going to learn about the if statement and the if-else statement. Let's take a look at the notes for today. Our warm-up task is to code up an empty main function in a file called conditionalfun.cpp. Go ahead and start working on that. We're going to use that file in order to code up very simple if and if-else statements. In C++, there are the reserved words if and else that are used as part of conditional statements, if and if-else. Let's start with a simple if statement. With a simple if statement, we want to write a Boolean condition that, when evaluated to true, will conditionally execute some code that we're going to specify after the if and the Boolean condition. So we start by writing if, and then we have parentheses, and in here I'm just going to put some pseudocode that specifies a Boolean condition. We know all about Boolean conditions now. Here's a great example of how they're used in C++. We have if some Boolean condition. Then we have these curly braces that group code together. Any code that is typed inside of these curly braces is called the body of the if statement. These curly braces are important for grouping code because code that's grouped as part of the body of the if statement executes when the Boolean condition is true. So I'm going to write body only executes when, and I'm going to use this abbreviation a lot in this class, BC, short for Boolean condition, when BC is true. Remember, Boolean evaluates to true or false. Our Boolean condition here, when it's true, will cause the code in between these curly brackets to execute. So let's take a look at a small example. Let's have a bool, and we'll call it something like is sunny. We'll stick with our example we were using in the last video. Now we'll have an if statement, and note how if shows up in the same boldface font color as return true using a namespace, which is an indicator that if is a reserved word in C++. Open parenthesis, and here's where we place our Boolean condition. So let's say our Boolean condition is very simple. It's just is sunny. And in here, in the body of our if statement, we'll print out it is sunny outside. Now let's add one more statement to our code outside of the curly brace. So this code will not belong to the body of the if statement. Let's just print out outside of the if statement. So we run this, and we see both of the outputs from our cout statements. So we start at the top of main, declare a variable called bool, a variable type bool called isSunny, set it to true, and then we have our conditional. If isSunny is true, so this is like saying if true, then we're going to do all of the code inside of these curly brackets, which is just a cout statement. So we have it is sunny outside because the Boolean condition of our if statement evaluated to true. Is sunny is true. And then I just have this simple cout statement that is not part of a conditional, so it always executes. Now, let's say we change is sunny to false. Now, on line number 8 on our if statement, when our Boolean condition is evaluated, is sunny is false, which is not true, which means we don't execute the body of the if statement. Recall, the body only executes when the Boolean condition is true. In this case, the Boolean condition is false. Save it, compile and run. And this time we don't see it is sunny outside. We just see our outside of the if statement. Though a very simple example, this clearly shows that if statements allow you to conditionally execute code. If a Boolean condition is true, execute the code in the body. Now, let's take a look at the else part of an if statement. Optionally, we can add an else clause after an if statement. An else clause looks like this: reserved word else, curly bracket, curly bracket. Note that there's no parentheses here because else's don't have Boolean conditions. The curly braces, just like with our if statement, define a body, and the body of an else only executes when the Boolean condition is false. Okay, this else is tied to this if. An if statement must have a Boolean condition. An else statement doesn't have its own Boolean condition because it is based on the Boolean condition of the if statement that immediately precedes it. That means you cannot have an else without an if. An else has to be tied to an if by being placed immediately after the body of the if statement. So I'm going to make a little note here. Else has no BC. You can think of the BC, however, as the complement of the preceding if's Boolean condition. So what do I mean by that? This else executes when the complement of this Boolean condition is true. So I'll make one more comment here. Kind of pulling together what we talked about in the last video about De Morgan's laws and complementing expressions, the logical operator, not. Else doesn't have a Boolean condition, but you can think about it as having the implied Boolean condition of not BC, where the BC is the Boolean condition of its preceding if, is true, not BC. let me show you an example so that this is more clear. We're going to add an else right after the body of our if. Remember, there's no Boolean condition on an else. But this will execute when not is sunny evaluates to true. Which is the same as saying is sunny evaluates to false. Very important that you see the connection there. So let's just add a cout statement so that we can clearly see the conditional execution. Let's leave is sunny set to false. So in the previous run of our program, we didn't see the cout statement of the body of the if because is sunny is false. But now that we have an else, and the else executes when the Boolean condition of the if is false, we will see our it is not sunny outside, which you can think about the Boolean condition of the else being not is sunny. So not is sunny when is sunny is false, not false is true. And there we see it is not sunny outside. Let's change is sunny back to true. And now we see it is sunny outside. One more important thing to note about if-else statements. The body of an if and the body of an else are mutually exclusive in terms of execution. Mutual exclusion means only one can execute, only one can happen. So our if statement, if the Boolean condition evaluates to true, this body will execute. This body will not. If the Boolean condition evaluates to false, the else body will execute, the if body will not. They're exclusive. Only one or the other of these bodies can ever execute on a single run of your program. Now, let's take a look at one more example and then we'll wrap up the video. It's typically good practice to use something called a model in order to describe an algorithm, either before you implement it, while you implement it, or after you implement it, to help document and explain what the algorithm does. So the model we can use in order to describe a process like conditional execution is a flowchart. And a flowchart is not unique to computer science. It's used across disciplines. So it's likely you have seen it before, or if you haven't seen it before, you will see it at some point during your education. So a flowchart is a model representing a process. There are different shapes in the diagram that are connected by arrows. A diamond shape, like you see here, represents a decision. And you can think about a decision like a Boolean condition. Something has to be evaluated in order to decide true or false. In the case of a Boolean condition being expressed in the decision of a flowchart, there'll be two possible outcomes, false or true. Those will be associated with arrows. Then we have our rectangles listed here. So inside of our rectangles is usually some kind of action, something that needs to be done. So here we have a really simple flowchart where we have a decision. We want to find out if the temperature outside is greater than 32. If it is, we want to display it's warm out. If it's not, we want to display it's freezing out. After we do one or the other of these two actions, recall mutual exclusion of conditionals, right? We can't have this evaluating to both true and false at the same time, one or the other. So after we do one or the other, then we continue execution sequentially until perhaps another decision needs to be made with a diamond in our flowchart. So if we look at this flowchart, we can code up a corresponding C++ program that will essentially implement an algorithm for this flowchart or this model. So let's go ahead and try it. We'll need a variable called temperature, and we'll need an if statement that, when true, displays it's warm out with a cout statement. When it's false, displays it's freezing out with a cout statement. Let's make this a little more interesting, and let's get this value for temperature from the user. So here's our task. Code up the flowchart from the notes. Get the temperature value from the user. You can use our if is sunny and our if else example here in order to implement this flowchart. But it'll be a little bit more complicated of a Boolean condition because you have a relational operator. So go ahead and pause the video and try this task out. First thing we're going to do is add a variable to store the temperature we're going to get from the user. Before we use a cin statement in order to get a value from the user, we should always use a cout statement in order to prompt the user so they know what value they should enter and they know why the program is hanging or waiting for them. Now we get to the new part. We want to code up this decision right here. We'll use an if statement to evaluate if temperature is greater than 32 for a Boolean condition. In the case this is true, we'll display it's warm out. In the case this is false, we're going to say it's freezing out. Now, a habit that I like to get into is when coding up an if-else, just put a one-line comment on the else line that says, what is the Boolean condition that would cause this else to evaluate to true? So that's going to always be the complement of the Boolean condition. Now this is still somewhat simple Boolean condition. It's not a compound Boolean condition that has logical ands and ors, so we don't need to apply De Morgan's law yet. But as our Boolean conditions of our if statements start to get more complicated, we will have to start applying De Morgan's law in order to figure out when will this else statement execute. So not temperature greater than 32, which is temperature less than or equal to 32. Let's go ahead and run this. Let's say the temperature is 65, and it says it is warm out. Let's say the temperature is 32. It says it is freezing out, which makes sense because our else executes when temperature is less than or equal to 32. And then let's say it's 0, and it says it is freezing out as well. Now, to wrap up our video, I'll give you one last task. Let's say we have an if statement where the Boolean condition is temperature is greater than 32 and is sunny is equal to false. So your task is going to be add an else with a one-line comment that shows the BC for the else, just like we did here. So I purposely constructed this Boolean condition for our if statement to include a logical operator. So you'll need to apply De Morgan's law in order to do this task. So I'll wrap up the video by letting you work on this. And to summarize what we covered here, we learned about conditional execution using an if-else. It was a good application of what we learned in our last video about conditional statements. And then we learned about modeling, specifically how to use a flowchart in order to model a decision that we could implement using a conditional like an if-else in our code.